fair warning, with this video, you're going to want a ruler, some kind of straight edge that you can use to draw nice, precise lines. So go grab it, pause the video if you need to. All right, we're going to talk about parallel and perpendicular lines a little bit further, deeper than we did before. We've seen this before. Remember, we learned that parallel lines have to have equal slope. Equal slope means that, for example, if one of my lines has a slope, let's say line number 1 has a slope equal to 1/3, 1/3, and slope number 2, that has a slope equal to that, then I know that these guys are going to be parallel lines. Perpendicular is quite a bit different. We got to do two things. Remember, number 1, we need to take the opposite, that's the opposite sign. So we need to change positives to negatives and vice versa. And then reciprocals, that's our flip across the line thing, across your fraction bar. So take the reciprocal as well as change the sign. Quick example here. If one slope is equal to 1/3, then the other slope has to have two things happen to it. I need to change the sign. So since this is positive, then I'm going to make sure my other slope is negative. And I'm also going to reciprocal it. So I'm going to flip that around and it's going to say negative with 3 on the top, 1 on the bottom. Better way to say that is -3. So that would mean that my slopes, or my lines, I should say, my lines will be perpendicular. Just abbreviate. Okay, so let's take a look at how to graph this, kind of putting some ideas together. Line number 1 has the equation of y equals 4x plus 2. So this is the really familiar, this 4 here is the slope, and our 2, that's our y-intercept. Line 2 runs parallel to that and passes through this point. So we've got a lot to put together. Let's just start with line 1. And line 1, again, your first step is to plot your point. Begin with your point. So step 1, let's put our y-intercept point on this picture right there at 2. And then the next step, we're going to use the slope to get another point. So that slope there is 4. Let's make that look like two numbers, 4/1. So I'm going to rise 4, 3, 4, and run just 1 over. And that's my second point. I'm going to do that one more time just for good measure. 1, 2, 3, 4, and over 1. So now I can draw that line in. Okay, this baby right here, this is line 1. Okay, line 2. Now line 2 has to run parallel to line 1. And so what does that help me know? That helps me with the slope. I'm going to go parallel. So my slope number 2, I want slope number 2 to equal the exact same thing it did in slope number 1. In fact, let me label this slope number 1. So slope number 2 is also going to be 4, or 4/1. And it's running through the point -3, 6. So my first step in this graph is to graph my point, -3, 6. And once I have that point graph, then I use the slope to find more points. So this is a slope of 4/1, up 4 and over 1. Up 4 and over 1. Now, if I did that a second time, I'd be off my graph. Let me just go down 4 instead. Down 4. And then I just back up 1, like I'm backtracking that whole idea, working backwards. So there's the points on my line there. And I can draw that line nice and straight with my straight edge. And those two should be running parallel to each other. So let's put on those arrows there. Okay, now another example of something you'll do, like in this next one, is you can see we're going to do some perpendicular. See, recognize that symbol there? So let's kind of take it through the same steps we did before. What's the slope for the first line? Slope of line 1 is equal to -5/3. Where am I getting that from? It's coming right from here, sitting in front of the x. It looks like I forgot to write on your note sheet there y equals. I'll try to fix that for you before I print this out. But that should say y equals -5/3 x plus 6. So the slope is -5/3. And the y-intercept is right there at +6. So let's go ahead and graph that. Come up here to +6 to start out, plot that first point, and then from there let's rise -5 and run 3. So rising -5 technically is really dropping. 1, 2, 3, 4, 5, and running across here 3. If it helps you, draw in the little distances that you do. I think that helps some of you. So -5, 3 on the slope. That gives me a second line. You want to do that one more time? 1, 2, 3, 4, 5, 1, 2, 3. Right here's the third point. Either way, 2 points or 3, we get the same line. So there is line number 1. And now let's tackle line number 2. Line number 2's got to go perpendicular. So our biggest challenge on this is to figure out what the slope is. Let's write this out. The slope for line 2 is going to equal, two things have to happen to change this slope. I want to see you guys change that sign. So this time it's going to be positive, and flip those numbers across the line. So positive 3 over 5. That's how our slope changes. And then we're going to just run through the point that they listed here for us. So let's actually start with the point. That's always the first step. Negative 4, 3. There's my point. And then rising 3, running 5. Both positive, so I'm going to come up 3. And I'm going to come across 5 to the right. And here's another point for me. And then I'm going to be able to just draw my line there. Okay, there's line 2. All right, let's mark that these are perpendicular by adding in the right angle marking. We should be right angles. If you got some corner piece of paper or something handy, stick it in there and see if they are really right angles. All right, so far so good. Now this next set, look at all these questions you get to answer. These are questions where we have the two equations, and we're just going to look at those, examine the equations, and determine if they are parallel lines, perpendicular lines, or maybe neither one. So the way we make that determination is we're hunting for slope. This is a slope hunt. What's the slope for line A? Line A's slope is equal to, right here, sits in front of the x every time, that's equal to 6. Well, what's the slope for line B? Line B's slope is sitting right here also, and it's equal to 6. So if those two lines have the same slope, then our conclusion is that they're parallel lines. So we write our answer as A is parallel to B. Line A is parallel to line B. And it's easy as that. Next example. What's the slope of line A? It's negative 7. And what's the slope of line B? Negative or positive 13. Do they have the same slope? Well, clearly no. So their slopes are not equal. Therefore, what kind of lines are these? Well, they might be perpendicular. I do notice that they did change the sign. Did they reciprocal the numbers? That's a no also. So this one's a neither example. Now, don't let those 20s sit in there fool you. They match, but those are not the slope. What are those? Those guys are the y-intercepts. The y-intercepts don't have anything to do with if the lines are running parallel to each other. Just hunt for the slope. All right, slope hunt, here we go. The slope for line A is right here as 6/5. Line B's slope is 6/5. That's a match, my friends. So I'm going to say that line A is parallel here. Line A is parallel to line B. Okay, coming in next. Line A on this one. Line A's slope is 9, and line B's slope is negative 1 over 9. Does 9 match negative 1 over 9? In other words, are these parallel? Not at all. They do not match. What about perpendicular? That's our next check. Well, those 9s are interesting. I see one's positive and one's negative, so it passes the first part. Does it pass the test of crossing the line? Is it a reciprocal? Remember, 9 is the same as 9 over 1, and so when it gets flipped, it turns into 1 over 9. That negative's on there. These are perpendicular. We've got opposite reciprocals. So let's say that line A is perpendicular to line B. Okay, what are you thinking on this one? Negative 2/3 is my slope for this one, and negative 3/2 is my slope for this one. I like that. Do you see how that flipped around? Negative 2/3 and negative 3/2. So that looks like it's perpendicular. So A would be perpendicular to B. But wait, not so fast. I hope I didn't fool you there. I was trying to act like it. I actually knew this. Really, I did. Did the signs change? Well, they're both negative. We can't have that. We have to have one positive and one negative. So in actuality, these are not perpendicular. So we're going to do the ninja slash, not perpendicular. There's the symbol. And they're not equal either. So this is another neither. Neither is the right answer here. Okay, last one. Look at the slopes here. We got a 2. We got a negative 2. They did change sign. They're definitely not equal, so not parallel. They did change sign, but did they flip? Did they cross the line? If one is 2, the other needs to be 1/2, and that's not the case. So we're going to say a neither on this one as well. Lots of neithers. There are some really specific tests. You know, make sure you have everything you want to have to be able to claim they're perpendicular or parallel. Okay, now our last examples are for us to write the equation. Write an equation, it says. And it says just an equation, so that means we get to pick the form. And you know me, I like that point slope form the best. So we have to write an equation that is a line parallel to this line. Oh, I love that number. It's so cute. Anyway, getting weird. All right, it's parallel to this line and running through this point. So if I'm going to use my point slope formula, then I'm just going to note here that my point is the 712 point, and my slope, I don't have my slope. All I know is that it's parallel to this line. Well, of course, I can figure out the slope of this line by just looking right there by that x. So if the slope of this line is -1/4, and I want one to go parallel, then I want to keep it equal. I want to just match that slope. So I'll just steal that slope from that first line to use in my new line. Okay, ready to write the equation. Like we learned last lesson. It's going to be y equals, and then I plug in my slope number. In parentheses, I'm going to take x minus my x coordinate, tack on that y coordinate at the end, and there's my equation. Now, for those of you who still love that slope-intercept equation and you're uncomfortable with this one, let's just simplify it. So it's y equals that -1/4, and -1/4 times by the x, we'll put an x there, and -1/4 times that -7, that's going to make a positive. It's going to be 7/4 if you love this fraction, and then bring down that plus 12. Okay, so it looks like I have to combine those like terms, and that's going to require me to get a common denominator. So if I'm going to get a common denominator on that 12, what would it be? Well, it's got to match this denominator. So I need this to be a 4 on the bottom, and that means I have to multiply on the top by 4. Okay, so let's see what we've got just right here. So it's 7/4 added to 12 times 4 is 48/4. And then everything else is coming down here, so -1/4 times x plus. Now I can combine these, and I've got a final answer of y is equal to -1/4 x plus, how many fourths here? 7 and 48 more makes 56/4. Take that for all of you who think that slope-intercept form is easier. I'm thinking I like this one right here. That's a lot easier to look at, a lot easier to find too. Okay, last example and then some for you to try. Let's go, this time we're going to write an equation of the line, and it's going to go perpendicular to the line with this equation passing through that point. So let me list this out again. I'm going to use the point of -11/3, and I need the slope. I can't write the equation without the slope. Well, how do I get it? Let's see if we can use this perpendicular line. This perpendicular line has a slope of a -1/2. So if I want to get a line perpendicular, I'm going to steal that slope, and I'm going to do two things. First thing I'm going to do is change that negative to a positive. Second thing I'm going to do is I'm going to flip those numbers across the line. So that 2 is going to come up top, that 1's going to the bottom, and I've got a +2, really. So slope is +2. Let's write our equation. Y is equal to our slope number of 2 times in the parentheses x minus a -11. Let's make that just say +11 and bring on that y value of 3. Okay, I like that equation. I'm good to go there. This one wouldn't be too bad if we want to simplify and put it into the slope-intercept form. So I'm just going to do that real quick. We'll call it good. Bring the 2 through those parentheses and call that 2x plus 22. Add the 3 onto that, and you've got y equals 2x plus 25. And there's your slope-intercept form. So we can give it in either form. Just depends on which one you like the best. Here's a little present for you. Enjoy. Do those, try these, and we'll talk about them tomorrow.